Okay, stop. I need you to hear this. The most powerful mathematical tool ever created, the one that put astronauts on the moon, runs every GPS signal on your phone and literally keeps commercial planes in the air, was invented by a 22-year-old kid who was basically hiding from a plague on a farm. And the absolutely wild part, he kept it completely secret for almost 20 years. Oh, and then someone else independently invented the exact same thing, and what followed was one of the ugliest, pettiest, most dramatic intellectual wars in the history of science. We're talking about calculus, and I know what you're thinking. Calculus? That thing that broke my brain in high school? Yes, that one. But here's what most people never tell you. Calculus isn't actually that complicated. What is complicated is the story of how it got here. By the end of this video, you're going to understand what calculus actually is, where it came from, why two of history's greatest minds nearly destroyed each other over it, and why it is literally running your life right now, whether you know it or not. Let's go. London in the summer of 1665 is an absolute nightmare. The bubonic plague comes roaring back. Within months, roughly 100,000 people die in London alone, nearly a quarter of the entire city's population. The streets go silent, businesses shut down, and Cambridge University closed, completely shut its doors, and sent everyone home. Now, one of those students sent home is a young man named Isaac Newton. He's 22 years old, not yet famous, no big wig, no knighthood, just a kid from a farm who is really good at math. He's stuck at a place called Woolsthorpe Manor, his family's farm about 60 miles north of Cambridge, with absolutely nothing to do. No classes, no social obligations, no internet, no distractions, so he just thinks really, really hard for about 18 months. And what comes out of that period of isolation is almost incomprehensible. By the end of 1666, Newton had developed the foundational framework for calculus, which he called the method of fluxions. He had also worked out his early theories of gravity and begun experiments with light that would eventually show that white light is composed of every color in the spectrum. History later called this Newton's Annus Mirabilis, the year of wonders. One kid, one farm, one plague. Three of the most important scientific breakthroughs in human history. Now, here's the part I promised we'd break down. Because calculus sounds terrifying, but it's genuinely not. Once someone just talks to you about it like a normal person, imagine you're in a car, cruising down the highway. Two questions pop into your head. Question one, how fast am I going right now at this exact second? Question two, how far have I gone total since I left the house? That is calculus. That is the entire game. The first question, figuring out the rate of something at a single instant, is called a derivative. Your speedometer is literally solving a derivative in real time. It's telling you your speed at this exact instant. The rate of change right now. The second question, adding up all those tiny little moments to get a total, is called an integral. It's like taking every single second of your trip, noting how fast you were going, and adding them all up to find your total distance. Derivatives and integrals. That's the whole thing. That's calculus. Now, why did Newton need this? He wanted to understand gravity. Not just things fall down, but the precise mathematical rules governing how the moon orbits Earth, how Earth orbits the sun, and how that force changes continuously as objects move. With regular algebra, you just can't answer that. You need math that handles things that are constantly changing. So he built it. And then, this is the part that genuinely makes me laugh every time, he just didn't tell anyone. For years, he sat on one of the most important discoveries in human history and said absolutely nothing. All right, real quick, before we get to the drama, and trust me, there is so much drama coming. Did you ever take calculus in school? Drop a yes in the comments if you did. Drop a nope if you escaped it. And if you did take it, did it ever actually click? I read every single comment. Okay, back to the story. Because while Newton is quietly sitting on his discovery in England, somewhere in Europe, a man named Gottfried Wilhelm Leibniz is about to change everything. Say that name 3 times fast. I dare you. Leibniz is in a lot of ways the anti-Newton, where Newton is reclusive, suspicious, and difficult. Leibniz is charming, socially brilliant, and deeply connected to every major intellectual circle in Europe. Diplomat, philosopher, polymath, a man who genuinely loved talking to people. By the early 1670s, Leibniz is working in Paris, and independently, completely on his own, from a totally different mathematical direction. He starts developing calculus, different notation, different approach, but the same core mathematical ideas Newton has been quietly hoarding. Leibniz publishes his version of calculus in 1684, making it available to the entire European intellectual world. It's elegant, it's clean, it's actually teachable. 3 years later, in 1687, Newton publishes the Principia Mathematica, arguably one of the greatest scientific books ever written. At this point, both men are celebrated. There's some tension, some awkward correspondence. Things are manageable. And then the gloves come completely off. By the late 1690s, Newton's supporters start publicly whispering that Leibniz hadn't really invented calculus independently at all. What follows is an international scientific war playing out across pamphlets, letters, and academic journals. Scientists across Europe are picking sides. It's ugly, it's personal, it's petty politics dressed up in the costume of mathematics. And then, in 1712, it escalates into something completely outrageous. The Royal Society of London, supposedly the most respected scientific institution in the world, announces an official impartial investigation to settle the dispute once and for all. Impartial. Here's the problem. Newton was the president of the Royal Society. He personally assembled the investigating committee. He handpicked his own supporters to sit on it. And then, historians have confirmed this, he personally wrote significant portions of the final report himself. The report that was supposed to be an independent, unbiased finding. The report found entirely in Newton's favor. Truly shocking. Nobody saw that coming. Leibniz died in 1716, bitter, isolated, and with his reputation in England in ruins. His own employer barely acknowledged his death. It's a rough ending to an extraordinary story. So, who was actually right? Here's the modern consensus. They both invented calculus, independently. Newton got there first, by roughly a decade, but Leibniz developed it independently, published first, and created a notation system that was cleaner, more elegant, and dramatically easier to teach. The notation we use today, the integral symbol, the dy/dx notation for derivatives, is all Leibniz. 100%. Newton's original notation essentially lost the notation war completely. Newton invented the concept. Leibniz invented the language we write it in. And then they spent years trying to destroy each other. Pattern interrupt, 5th grade mode. Okay, no formulas, no textbooks, just what this stuff actually feels like. Picture a ball rolling off the edge of a table. Gravity grabs it. It's not falling at a constant speed. It's accelerating, getting faster every tiny fraction of a second. Someone asks you, at the exact moment it leaves the table, how fast is it moving with regular algebra? You can't answer that. Algebra handles averages and fixed numbers. But here's how a derivative solves it. You zoom in on that exact moment, like zooming into a photo, until the curve looks almost straight at that tiny scale. And the slope of that straight line, that is the speed at that instant. That is your derivative. Newton called this a fluxion, the rate of flow at any moment. Leibniz called the tiny steps infinitesimals. Quantities infinitely small but not quite zero. Different words. Same beautiful, brain-bending idea. Now, integrals. Imagine a weird, curvy, completely irregular shape on paper. Not a square, not a circle, just some random blob. You need its area. Here's what you do. Slice that shape into thousands of super thin rectangles. Add up all their areas. The thinner the rectangles, the closer you get to the real answer. Now make them infinitely thin, infinitely many of them. Add them all up. That's an integral. And the infinite symbol? It's literally a stretched letter S from the Latin word summa, meaning sum. Leibniz designed it specifically to represent summing up infinite tiny pieces. That's thoughtful notation right there. And here's what's wild. Calculus is built entirely on infinity. Infinitely small steps. Infinitely many additions. And yet it produces exact, precise, real-world answers. It should feel like it doesn't work, adding up nothing forever, and somehow getting something. And yet it's accurate enough to land spacecraft on the moon. Your GPS. Every time you open a Maps app, your phone communicates with satellites orbiting 20,000 kilometers above you, moving at 14,000 kilometers per hour. The math required to triangulate your exact real-time position as both you and the satellites are moving, that is differential equations. That is calculus. Medicine. When a doctor prescribes your dosage, that calculation models exactly how your body processes the drug, how fast it absorbs, when it peaks in your blood, when it drops below therapeutic level. That entire framework, pharmacokinetics, is built on calculus. Dosing someone wrong means the drug doesn't work, or it kills them. Pixar movies, every fluid, realistic animated movement, water splashing, hair swinging, fabric rippling, is physically simulated, say, using differential equations from the same principles Newton and Leibniz developed. The same math Newton used to describe the moon's orbit is making animated characters feel real on your screen. Artificial intelligence. When AI models train, the core algorithm is called gradient descent. Imagine the AI's wrongness as a landscape of hills and valleys. Gradient descent uses derivatives to find which direction is downhill and takes a step that way billions of times until it reaches the lowest point. Every AI interaction, every streaming recommendation, every search result, gradient descent is running underneath it. Calculus is running underneath it. Newton's original problem was simple. How do planets move? He built calculus to answer that question and accidentally created the mathematical infrastructure of the entire modern world. Here's something genuinely unsettling in the best way. Calculus was invented by two specific, flawed, brilliant humans to solve one specific problem. And yet, it turns out to describe reality with stunning accuracy across completely unrelated fields. At scales Newton and Leibniz couldn't have imagined. The physicist Eugene Wigner called this the unreasonable effectiveness of mathematics. Abstract structures invented purely in someone's mind end up describing the physical world with jaw-dropping precision. Is mathematics something humans invent, or something we discover, something always embedded in the structure of reality, waiting to be found? 1665, a 22-year-old named Isaac Newton, near complete isolation. A deadly plague killing tens of thousands. No distractions. Just a relentless mind and an unsolved problem about how the universe works. In those 18 months of quiet, he builds the tool. A decade later, a charming German philosopher named Leibniz, working in a candlelit Paris study, independently arrives at the exact same tool. They could have shared the glory. They could have been co-founders of modern mathematics and gone down in history as collaborators. Instead, they spent the final decades of their lives trying to ruin each other. Leibniz died in 1716. Newton died in 1727. The dispute continued after both of them were gone. And calculus? Calculus went on without either of them. The speedometer in your car. Derivative. The GPS rerouting you around traffic. Integral. The AI learning your habits. Gradient descent. Calculus in disguise. All of it traces back to one bored, brilliant, plague-avoiding kid at a farm in Lincolnshire, and one charming philosopher in a Paris study. If this video made calculus feel even a little less scary, or if the Newton versus Leibniz drama gave you that what feeling, share it with someone who thinks math is boring, because history just proved them completely wrong. Next video, the single equation that changed the entire course of World War II. See you there.